Good morning, everyone. My name is Eric Romo. I am the DS23 tutor at Fresno City College, and today we'll be talking about probability. Now, some fundamental definitions of probability that I want to go over first with you is that any probability must be between 0 and 1, and that the sum of all probabilities of a sample space must equal 1. And that's a very important concept because if we notice we're always working with a couple of fractions in probability or decimals. So if I had a probability distribution, okay, say that 0, 1, and 2, and let's say that I was drawing cards or something, and I got no, and that was point 0.3, and this is point 0.3, and this is point 0.3. 3 through 3, 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 or 1/3. If I added all of these together, they should total out to 1. And in fact, they do. 1/3 plus 1/3 plus 1/3 is, in fact, 3 over 3, or 1. So, that's just the basic concepts of probability. Now, I have a problem here that is listing to me that I need to find the probability of drawing a queen from a deck of cards with replacement what is the probability? Now, right here, I have my general equation of a probability. What this is saying is that the probability of the event that I am looking for divided by the probability of the entire sample space, or all the elements. So, I have in a deck of cards diamonds, hearts, clubs, and I also have spades. Now in this deck, we're assuming without jokers, in total are 52 cards. Now, each of these suits, since there's 4 of them, 52 divided by 4 means that they must have 13 cards each. And we can in fact count those. An ace all the way to a king would in fact total out to 13. So, I am looking for drawing a queen from a single queen from a deck of cards without replacement. What is the probability of drawing that? Well, the event in question here is really how many queens are in a deck. There's a total of 4, and they fit that event that I'm talking about, a single queen. So, I'm going to put on the top of my fraction here a 4, because that's the event, a queen. There's 4 total queens in this deck. Now, the probability over the entire sample space. Well, I already know what my entire sample space is. It's 52 cards. So, in fact, if I were to reduce this fraction, 1 out of 13 is my probability for drawing a single queen. Or if I were to put that in a calculator, 1 divided by 13 0.07. If I were to round it, 0.08. And if I even wanted a percentage, that'd be 8% chance. So, if you were playing a deck of cards with somebody such as poker, you have an 8% chance of drawing a queen from a deck of cards. Now that's in the beginning though, and that's without replacement. Notice that in here, I was with replacement, okay? So what's going on is that you need to be careful of when it says with replacement versus without replacement, because if it was without replacement, I'm not putting the cards back in the deck. This was assuming that I was putting the cards back in the deck. So if I were to draw another card, let's say I want to draw another queen, I already took one queen out of 52, which means I need to minus 1 from the top and 1 from the bottom because the sample space has been reduced. It will become 3 over 51. So your chances will increasingly get smaller and smaller if it's without replacement. Okay? And that's all there is to it for some probability rules and some simple understanding.